Hello, everybody. Ready for the last last event of the event. I guess we could do quick intros if anyone hasn't been at the talks. My name is David Mihal, and I'm at Fuel Labs, but I will be a neutral moderator. Do you guys want to do quick intros?
Sure. Hey, I'm Raul. I'm an engineer at Arbitrum, working on our VM that is compatible with EVM semantics.
And I'm Carsten Munk. I'm from the Cartesi Foundation and a board member there, but I also dabble a lot in the technical parts.
Awesome. I'm Nick, the CEO of Fuel.
I'm Rahul. I just gave a talk. Engineer and product manager at Aztec.
I'm Bobbin. I'm with Polygon and leading Polygon Miden.
Cool. And so the theme of this talk is, I didn't even write it down, but I believe it is general purpose VMs versus custom VMs. I guess someone made the point that they're all, in some sense, general purpose VMs, but I think by that we meant kind of purpose-built, like blockchain-oriented VMs versus environments that are more general purpose and taking those to be on a VM. And I don't know, to keep this interesting, I want it to be, I want it to be like a debate. Everyone's super nice here, but I want some like arguing or something. So I wanted to try to kind of like segment the projects here into those two categories. I mean, I kind of have my take on it, but I figured it's probably better to just, it's a bit of a spectrum. So for each of you guys, would you say you are a general purpose, you fall on the general purpose side, or are you building like a specialized VM? I guess you can go first, Raul.
Sure. It's hard to say. I mean, our main thesis is that the EVM network effects, and when I say the EVM network effects, I specifically refer to the tooling built around the EVM, right? And what developers are used to, what applications are live today in production, what people are using, and we feel like we need to preserve those properties. And of course, like deep down, we're doing that through WebAssembly and through our runtime, which is a general purpose WebAssembly runtime. So I guess my hot take is really that we should just really preserve the compatibility layer and the network effects there. And underneath the hood, it doesn't really matter for us. We just care about efficiency and cheap costs and just speed.
Yeah, so for Cartesi, I think that we are quite a general purpose VM because we can run RISC-V, we can run Linux on it. And my definition of a general purpose VM is a VM that you easily can run Doom on.
That's a great definition.
Yeah, that's always the test of a good virtual machine. Yeah, so with Fuel, we're definitely a specialized VM, so not general purpose. And we went that route because we wanted to tailor the way the instructions work, the way memory works, the way storage works, the way the entire thing functions for the very tough and adversarial environments that blockchain typically presents. And so we wanted to build something that had the level of specificity and determinism and safety that blockchain would typically need. So for us, definitely more on the specialized side. Yeah.
Yeah, I guess this is a bit of semantic one. Generalized in the sense, no R is Turing complete. You could do what you want, but specialized, obviously, because we're focusing on adding privacy on top. So both.
Yeah, and from Miden, I would say we're more on the specialized, much more on the specialized side. And I think, again, like there's different levels. Like if you talk about like general purpose, like there are like x86 type of general, then there is like EVM type of general, and then there is like even more specialized than that. And you can pick where you want to be in that spectrum. And I think, especially like in the ZK context, it makes sense to build something it makes sense to build something special, especially if you want privacy, because like that doesn't exist in any of the general purpose environments, whether it is EVM or x86 or whatever.
Perfect. I think that pretty much matched my mental model of I kind of had like Cartesi at one end, Arbitrum pretty close with being WASM based, and then Miden is kind of closer to the other end, but then like probably Fuel and Aztec being pretty like special built VMs. I think sounds about right.
Yep.
Cool. Before we kind of unlock that, before we like kind of fully dig into our VMs themselves and kind of the different like trade-offs and decisions you guys have made there, I wanted to like back up a bit and look at kind of how we've reached these architectures. So, obviously the dominant VM across blockchains right now is the EVM. We've been talking all day about kind of a lot of the different problems and challenges, but I'd love to hear quickly, like, what do you guys think is kind of the main challenge that is, holding the EVM back that you think is like best addressed by breaking away? Because obviously there's a ton of network effects there. Like, why do we need to break away from the EVM?
See, so at the VM layer, I think we absolutely need to break away into more efficient execution methods. Like one of the biggest drawbacks is that in most implementations of clients today, the EVM is interpreted, right? So it's extremely slow compared to something that is closer to natively compiled. So like with WASM, we're able to do just-in-time compilation and get really fast results because it's just that much different when you're running something that's native to your machine than at the EVM layer. Instead, we want to preserve compatibility at the upper layers of the stack, right? Like the applications people are building, how they're deploying them, how they're interacting with them, that needs to stay the same. And can be gradually improved, and we have the ability to customize and do things a little bit differently, but we want to provide that option that compatibility is there, right? So with Stylus, we can do things, we can introduce a lot of fancy things that maybe EVM tooling doesn't have available, but we still support EVM compatibility. So people have the choice, and we think that's what matters for us. And yeah, so we want to innovate at the execution layer, but support and extend the composability layer.
Yeah, so from Cartesi's side, like the EVM certainly has its purpose and it's been proven in being absolutely fantastic for blockchains, or to some extent fantastic, and it's something that's there right now for us. But there was a talk earlier today where somebody was saying that like everybody knows Solidity, but this is a very narrow view on a very small sample of people, right? Like there's definitely more people out there that know JavaScript, right? There's people that know Rust, and I think that in terms of kind of like actual developer adoption, like I honestly think that EVM has failed in terms of actually getting developer adoption because there's so many people that wanted to get into blockchain, but they felt that it was like a mountain to climb. Of course, the security and so on, but
It's a good hot take.
Yeah, I mean, so from my perspective, so I've been building with Ethereum almost since it started. So I think like 2015 or 16 was when I really started to post a lot of stuff. I've been using Solidity since version like 0.6, and I was using Aleth 0, so I don't know if anyone in the room goes way back to Ethereum's beginning, but basically been using everything from Ethereum for a very long time. And I think fundamentally what I felt was all the time was that the Ethereum Foundation pushed off a lot of the tooling work to the community, which ended up highly fragmenting the solutions for just general tooling, and it lacked a lot of cohesiveness. And it took many, many, many years to get to the place that it's at now. And I think it held the ecosystem back significantly in terms of developer adoption, and we missed many, many good years because of it. And so I don't necessarily think that designing languages or tool chains for your VM is the wrong approach. I actually think designing the right tool for the job for the VM is the right approach. It's really great if you can do it. General purpose ISAs or WASM, et cetera, all interesting approaches, and they're really cool. But I think I just felt like in general, the tool chains and the languages and what was available for Ethereum was never really quite there, and it lacked a lot of vision as to how it would all function, which is very unfortunate. But still, the community, because of the values of Ethereum, what it was, it pushed through, and eventually we got some pretty decent tooling and stuff like that out of it. But yeah, I would say that like for Ethereum's sake, there's a lot of room to grow. Yeah.
So I think there are like two reasons. Actually, one of them I'll steal from a panel I was with Nick last year, which is over the last 6-7 years, the way we've used blockchains have considerably changed, and new problems have come up, ones that we couldn't have thought about before. MEV, seed phrase, creating and managing accounts, always been hard. Many other problems that we're still talking about, scalability being one of them. So like creating your own custom VM would mean you can finally solve some of these. You can be opinionated about which solutions you want to solve. The second thing is innovation. we see like a lot of dApps now, there's much less innovation now in terms of like brand new architectures at the app layer than before. Creating a custom virtual environment with custom features would mean you kind of break people's mental models and enable them to think again like we were when we were kids. For example, somehow, because everything's public, we've decided you shouldn't do identity. You shouldn't have real-world assets becomes much more problem. Maybe the bet for Aztec is when you add privacy, you can stop that. You could get identity finally on chain. You could do much more things in a much different way. So I guess innovation and just the inherent baggage of having EVM could be two reasons why we shifted.
Yeah, I would say basically there are probably a lot of deficiencies in EVM that are small and like, kind of fixable, like dynamic dispatch and safety and all of that stuff. But I would say there's probably three main reasons why you may want to develop your own like instruction set or your own VM. The first one is EVM transactions are built in such a way that they're very difficult to parallelize. You want, like, if you want to scale beyond like a couple thousand TPS, you need to do parallel transaction execution, and you can get it with EVM, but it's like kind of like chewing glass to get it with EVM. The second one is privacy. Like, it's very difficult to get privacy on EVM, and even if you count like with ternary cache and things like that, it will be more expensive to use privacy than it is to be non-private. And that model, in my mind, doesn't really work, because if privacy is more expensive than the other alternative, people are not going to use it as frequently. You want to make it so that privacy is cheaper option out of the two. So if you want to be public, then you need to pay extra, and then by default, many people will be private. And then the third reason, which is probably less of a reason now, is like, but at the time when we started, we were not even sure you could like practically prove a VM execution in ZK context. That was not like, now this problem is kind of solved. We have ZK VM and Polygon, which runs. Again, it requires a big server and all of that, but it is practical now. So I would say much less of a reason now, but at the time when we started, we didn't go with EVM because we just were not sure we could do it in a practical manner.
Awesome. I think that was a great background on some perspectives and design decisions. I want to jump into, kind of like breaking down these two different approaches. Nick touched a bit on kind of the tooling landscape, and I think depending on which approach you take, you get a very different tooling environment. As Nick was saying, if you if you build a new VM ecosystem from scratch, you have to build a lot of tooling with it. It's nice you can have your tooling be cohesive, but it's a lot of work to do. Whereas if you use existing things like using Rust or Python or something like that, and your VM supports that, you get to tap into that ecosystem of tooling, but again, it might not be as oriented for blockchain. So I'm curious how you guys think about tooling, like which is the right approach? Why does it make sense to do one versus the other? And anyone feel free to jump in. We don't always have to do round robin.
We don't, but we could. We could just do it again.
That's true.
Yeah. Well, I'll say, I'll start off. So for tooling, it's really perilous to build your own tools. We've been doing it for Fuel for the past few years. And, we're just getting to a place where I'd say it's almost, ready for everyone to use. But it's taken many, many years and a lot of work to get the tooling to a place that, the custom tool chains to get to a place that feels good for a developer. So building your own tools is really painful, and building your own language is really painful. Building your own stuff is very, very painful. But I would say the benefit is that once you've done it, once you've gotten to a place where you've gotten enough out of it, the benefits could be enormous, because now you have a really tailored system to target your environment that really understands all the different contexts of your environment. And it makes things like auditing and debugging and really understanding the machine design of everything far easier. So it's a big lift, it's a huge job, but if you can do it, the reward at the end of it is fantastic. But of course, for general purpose stuff, I would say, using Rust and Wasm and all that other stuff has its benefits too. So, yeah.
Just one question. Would you prefer building your own tools or like letting the community build one?
Yeah, so I think with Fuel, we kind of saw how letting the community build the tools went over the past few years and decided to do some of that ourselves. But I think we're really just trying to get the tooling started and trying to get it to a place where you can ship really great performant apps on it, and then allowing the community to take that vision and then forward it. It would be maybe a better approach than having the community do everything, because I think that was the big failure with Solidity in a sense, was just like, there was very few people maintaining it, there was very little coherency in the tool chains, and again, I think it really hampered adoption a lot.
Yeah, I don't think that customized tooling as itself is a problem, because even if you're looking at, let's say, cloud computing today, right? Like there's customized tooling in order to, for example, deploy something to AWS, or different mindsets of doing computation, like let's say Lambda, and there's nothing outright wrong with that. But the challenge has always been that as you're also saying, that left up to the community. But essentially, what has happened is that they have externalized the problem to somebody else, right, and letting them solve the problem.
Decentralization.
Yes, decentralization, but not in the good way, right? And I think that it's all about kind of like we're nowhere if developers can't use things, but at the same time, there's also a specialization to doing blockchain application. Of course, if you're building something that needs to handle high-value stuff, then of course, similarly to how you would develop, let's say, secure enclaves or something like that for transactions, of course you need something specialized for it, proper tooling and so on. But why does it need to be so damn hard?
Yeah, one interesting point about using tooling in a general setting is, and this potentially a problem, is the tooling from say WebAssembly might not be well suited for blockchain, or is it well suited, and how can we measure that, right? Are we trying to maybe fit a square block into a round peg? And that's something to think about. However, the WASM ecosystem has evolved so much that it enables things that we didn't think would be even possible. So something that was exciting about using tooling that is very public and used in kind of the Web 2 domain is that recently a developer wrote an NFT that they were able to render with the same exact contract code in the browser because it was written in Rust and compiled to WebAssembly. So we see these interesting things that arise when it seems like maybe the tooling might not match the domain perfectly, but developers find interesting ways of bringing it out to light. However, we do believe that by relying on the massive community and ecosystem that WebAssembly has fostered, we're able to reap a lot of benefits. It's hugely supported by the web standards committees, of course by the different browsers, and we just get all of that for free from building on it.
I think in terms of tooling, there is probably a spectrum of things you can choose, right? And different approaches that you can take. One of the conscious decisions that we made for Polygon Miden is that we decided not to build our own language, because while we are our custom VM and things like that, we will build a compiler that will compile from other languages. So we would much rather use Rust or maybe Sway or other languages, and hats off to people who develop their own languages. This is we decided that it's a monumental challenge, and kind of on the spectrum of how much tooling we want to build, we decide we'll go up to the compiler, but not beyond that. But even building the compiler is it's a fairly significant challenge, and all other things you still need to, with EVM approach, you get indexers and block explorers and all of that out of the box, which you probably still need to build for custom things. But yeah, I think you can pick and choose where on that spectrum you are and how much you want to bite off.
Absolutely. To push back, I guess I'll first push back on the pro build your own tooling side of in the EVM world we saw we've gone from kind of Truffle to Hard Hat to Foundry, and kind of maybe it's debatable, but I feel like each one of them was a progression above the next. So Nick, you were kind of saying when you leave it up to the community, it gets messy, but does that messiness not ultimately lead to kind of the best experience versus a top-down design?
Yeah, I think one thing that when you do your own tool chains and you do your own stuff, the issue becomes then you look at other communities and they might have advanced certain features that you just haven't even thought of yet. That's just a good idea, but you haven't even gotten to it. I think community development with the right setup can work for certain settings. Foundry, I think works really well because Georgios really set up how committing to Foundry works really well. But it's very hard to do in a community setting versus doing it by a single organization. And I would say that there's pros and cons to both, so you're not going to get everything. It's just like physics, But I think what you do get is when a single org at least starts it off, right? Maybe doesn't always do it, but just starts it off. They can at least make all of the experience coherent of developing with the system, all the way down from the language, every tool down to the language, down to the VM. And I think that kind of customizability is and control is very, very important for developers to feel like they can really get all the power out of your system, versus like just using all kinds of general purpose tooling that wasn't really designed for that job and trying to make it feel normal when and everyone knows it's not. It's definitely not what it was designed for. So that's the way I would approach it.
I guess I'd push back slightly on some of the small things, which is like, when you're starting with a custom blockchain, etc., you have to create your own tooling from scratch, right, as the founding team for the blockchain network. But there's a very small line, like you could either make it completely like monolithic and have everyone has to use that, and eventually once the network is stable, you hope that community picks up and there's some smart people who can do it. I think the route we're taking is like modularization, not just because it's a buzzword in blockchains, but turns out it's just good in computer science, in the sense that you have this smart contract framework, you can build it into multiple different libraries, and people can use this one library, and then they hate your implementation of the other library, like your storage implementation, and they can just write that and swap in and swap out kind of thing is the route that we're planning to take there.
To kind of flip things around to the other side, if you're using general purpose tooling and maybe general purpose languages as well, do you guys see there being any issues with security, given that these languages and the tooling and things are often not made for blockchains, economic systems? Usually they're made to run like web servers and stuff like that. Is there any risk involved in using general purpose like non-chain tools?
I think there's always a risk to using any kind of source stuff. Is there anybody here who's actually checking the checksum of the Solidity compiler when you actually download it? Right? That's a problem here. That's a problem that, why aren't we already doing reproducible builds of our tools in this ecosystem, right? Because we explicitly trust the Solidity team. Of course, there's a TPT signature or something like that, but why can't we go in and see on the actual blockchain that there's let's say, an undisputed computation about that this Solidity code was built into it? I mean, with something like general purpose virtual machine, you can already now compile a Rust binary and get the exact same thing out. You can build a Docker container, you can build Solidity for it, so why aren't we doing those kind of things right now? It's all about supply chain, and if there's anything we should know about in crypto, is about the supply chain, because we get hacked all the freaking time through the NPM packages.
We chose WebAssembly because it's being battle tested in possibly the most adversarial environment comparable to crypto, which is web browsers and the internet. So standards committees and the different browser engines have put in a lot of thought, and companies are using WebAssembly in production in the browser today. So we leverage all of that. And because we only need the deterministic part of the WASM specification, we're able to constrain that even more. But agreed here that there's always risk, of course, especially when the domain can be a little bit different than blockchain from where this tooling comes from. Nonetheless, we chose technology that is being used in production outside of our own creation.
I guess one question too for the WebAssembly side regarding security is if with WebAssembly and general purpose languages, one really nice thing is it lets you bring in external dependencies. But do you guys see that as well as what's the security properties of that? How do we make sure that if developers are pulling in crypto libraries and stuff, that it's still running as securely on chain as like a crypto native tool chain?
We can't stop bugs in crypto libraries, of course, but yes, I mean, you can use things that are already heavily audited and heavily used. So as an example is, we deployed the BLST, which is a popular BLS signature verification library that actually Ethereum uses in production, and it's been heavily scrutinized, and it's, although it's written in C, for maximum performance, it has so many eyes on it, it has so many people trying it out. So it's also about educating developers on what to do, what not to do. Don't roll your own crypto, for example. But of course, if bugs come from those crypto libraries and they deploy them on chain, we can't stop those bugs.
And I would say you probably don't want to limit. I mean, if you limit it too much, it stifles innovation in ways like you want to allow people to bring in new signature schemes or new hash functions or whatnot, because it allows. It comes with a risk, and maybe you need to educate people to say like, okay, this is like standard or what or standardized, or we kind of like community has evaluated and like vouches for as much as possible for the kind of correctness of the code, but you're free to bring whatever else. Like if you want to have a post-quantum secure signature scheme, hopefully we'll go with something that is NIST approved, but if you develop your own thing, you should be able to deploy it. It's up to you. I would say I don't think we should be opinionated in that regard.
Yeah, I would say, using any tool has the same risks, right? Like, regardless if it's open source, unless you apply checksum matching, you don't know if you're actually using the right thing. We're writing a lot of custom cryptography for Aztec. We're using Wasm, of course. Like, I think anything with ZK in the browser has to use Wasm, because crypto usually written in C++, Rust, and you have to put that on the browser. The one great thing about that, though, is you write your blockchain environment with a security-first mindset. I think weirdly in blockchains, like the current status quo seems to be you first write your dApp or application, and then you pause work for 6 months, then you audit it, and then you launch, as opposed to the standard practice, which used to be like while you write, you test, and you have a security engineer that also does pen tests at the same time. So I think that's like the continuous like CI/CD kind of pipeline. The continuous pipeline of testing is way more important, because sometimes you just can't do anything, right? Like our founder came up with Plonk a few years back that is just custom. A lot of ZK rollups are using that. The only way possible is you either stop doing ZK stuff there, or you just continuously, rigorously security test, and of course do the audit. But I think the worst idea would be to just not do any security, write your application, roll up in our case, and then do an audit.
Yeah, I think one of the things that is also important to kind of like sometimes remember is that we, of course, in this business, we go automatically to cyberpunk-like security, right? Like the government shouldn't be able to take us down. But there's many, many blockchain use cases that is more about, let's say, smaller governance to some extent, where these kind of use cases might make sense. It might be they evolve into like some autonomous like organization over time, but does everything need to start there? Instead, we should be giving people the tools to actually make themselves more secure over time.
I think, Bobbin, you raised a good point about standards being a big part of kind of blockchain development, but including in relation to security. That some security comes from kind of the architecture of the chain and the libraries and stuff like that. A lot of it will just come from the community in terms of what tooling not just tooling, but like what libraries they use, what interfaces. I've certainly been a big critic of the ERC20 standard. Well, I guess how do you guys think of standards? How much should the language, the environment kind of enforce these standards? How much should the community enforce it? How much should it be flexible to allow kind of like experimentation and different types of applications? What do you guys think about that?
I can actually start with this. This is just sort of like a minimalistic approach, but like I think enshrining the least amount of things seems to be the way to go forward. If you enshrine a certain standard early on, new rollup, new application, you will encounter new issues, and then you kind of just have to sit through it. So like maybe a good middle ground is like putting out reference implementations in the terms of tutorials, because once again, you're building custom VMs, right? Like Arbitrum Stylus, you still need you still need to have reference implementations of even ERC20s. Same for all of us here, actually. I think the best is like to get the community to come up with a standard, or even like think about what they could look like, and just have old school design decisions, design requirement analysis on them. But it should never require changes to the protocol, for sure.
Yeah, I would just say it really sucks getting to an architecture and then being a dev and then looking up how do I build a token, and it's not answered, like how the structure of everything should work, or at least what a reference implementation would be. So I think for certain things, standards are going to be really important, particularly tokens, particularly fungible and non-fungible tokens. I think defining some other standards as a starting point for any new tech, any new VM, or any new environment is probably the first thing that needs to get done. I think with certain architectures, like Fuel or Move, for example, assets are already native to the system, so it's really just how you standardize some of the metadata versus like the actual implementation. Like in that sense, it's more enshrined. But I would say that like it's incredibly important to define those things. Probably everything else is sort of up in the air, I would say. But I think certain key standards to launch are really, really important. Yeah.
Yeah, so in terms of standards, like if we're looking at something like RISC-V, it's a specification and a standard and how you do things, but it also comes with a boatload of test cases, right? I can actually confirm that my virtual machine is acting according to kind of like how it's supposed to be. Of course, there's the occasional kind of exceptions and so on. But for example, there's no such thing as, I don't know if there's, well, I might be wrong here, that there's no such thing as a very wide test suite for ERC20, how it's exactly supposed to behave, because at least I remember there's been a lot of mess-ups in terms of like how different tokens are supposed to react to things. So it's not just about standards, but also about test cases, about how does these things evolve. And this is one of the standards is one of the most difficult things to do in the world because everybody has their own incentives. And I think that we can also learn a lot from kind of like how internet standards has been produced in terms of the IETF and so on.
Like how many funds have been lost to a proven transfer from,
yes.
You know? Like that's a good starting point, you know? Yeah, exactly.
I think my perspective on this is like basically to enshrine as little things, as few things as possible in the actual like core protocol design. So like do not enshrine signature schemes potentially. Like Miden doesn't enshrine signature schemes, doesn't enshrine basically anything. Like there are a few things that we specify, like because of the ZK context, we have to say like this is the hash function that you would use because it's the most efficient one in the ZK context. But aside from that, like we don't even specify like how an account has to look like. And my kind of our approach to this is that we want to provide standards right from the start. Like this is what a token contract looks like. This is how a basic wallet contract looks like. This is and a few other things. But then we'll provide a default signature scheme that you can use, but you can bring your own. But basically, you come up with the standards, but you should not be, or you should be able to like change the standards without breaking underlying or have to change the underlying protocol. So like if you want a different token standard that's still interoperable, like hopefully with the previous, like you have to define some things, but as fewer things you have to fix, the better it is. Like, that's our kind of approach.
Yeah, I mean, to kind of like build off that a bit, like you're talking about, yeah, hopefully you never need to kind of, change core, like enshrined things as things go on. But of course, some features will be enshrined in a rollup. The architecture of a virtual machine will inherently enshrine some things, whether it's some cryptography or something like that. And of course, the blockchain space moves very fast. My feeling is that right now the execution space is going to start moving even faster because we're kind of reaching maturity at the consensus layer. So given changes in kind of the whole ecosystem, we will have things like intents and PBS and stuff like that. How do you see your architecture is being able to adapt best to the upcoming changes?
No changes to really adapt to from our side because we're purely just an execution change. As long as Arbitrums keeps supporting kind of the EVM equivalents as much as it can, then we should be fine. I think it's exciting to see just the new things that we can introduce while maintaining compatibility. So interesting things, and these might not be coming, but there's some ideas is we could implement rentable storage as something that we could do on Stylus while maintaining EVM compatibility for Solidity EVM smart contracts, right? So we have a lot of flexibility there. So like you said, consensus, things are coming to the consensus layer. As long as we support those, we're free to innovate on execution.
It's a cool idea.
Yeah, you give an example of PBS. So Aztec will be launching with decentralized sequencing, and one of the first questions that we came up with when designing such an algorithm was, currently, if you look at validation on Ethereum, you have PBS that's not enshrined, right? Flashbots. And there is talks that maybe Ethereum should do PBS. It's not confirmed yet, right? And we were thinking a lot about, hey, should we enshrine PBS already? Because we know the issues that came up with the Flashbots relays, or do we not, right? For us, the problem goes a step further because we don't just have the sequencer, but we also have a prover. And then you go like, okay, so do we enshrine a decentralized proving mechanism at all? Or do we let the sequencer decide? So they could even give it to Gevulot or some other third-party proving marketplace, right? So some of the things that Aztec's done is, for example, on the private side, we don't have a VM. I think Miden and everything is a VM, so we only have that for public, but private, we just don't have VMs or opcodes. We just use circuit proofs as a way to like tell the rollup that things were done correctly. For sequencer selection, we decided to do PBS. We decided not to enshrine PBS for the simple fact that it just seems risky. It's something even Ethereum is still considering. They aren't sure, and they've been live for many, many years at this point. But also means you can do many other things, right? Like once you don't enshrine PBS, you also mean that the sequencer could act like a prover, or that sequencer can decide to be lazy, just do sequencing, and give the proving side to a random third-party marketplace or just a friend that they know that does proving, kind of thing. So I think the biggest problem is like you don't know what innovation will happen soon, and you want to be future compatible with innovations that can happen, which you don't even know about. And it seems like the best way for now to do that is like enshrine as less as possible. There are like many examples in the Aztec side, but yeah.
Yeah, I mean, in terms of enshrining operations, like right now, the FuelVM has a few cryptographic operations. So SHA-256, KeyCAC, and a bunch of different signing curves, P256, et cetera. But in the future, we would look to actually just use an implementation of that on the FuelVM because itself, the FuelVM is very, very efficient. So once we optimize things more and progress things more, we'd look to actually get rid of the enshrined things, in which case you can target the FuelVM very much like you would target any WASM context. But enshrinement is important now just to move the process along. But in the future, we'd aim for that level of optimization. So I agree with the enshrinement point entirely.
Cool.
How would you remove enshrinement? Like, would you just upgrade the protocol? Would you like hard fork?
Yeah, well, so we're pretty anti-monolithic in terms of our thinking. So we would expect there to be many thousands of fuel chains and fuel VMs running. So over the time of people deploying more of those, you would have newer versions and newer upgrades. Yeah, with that in it. Yeah.
So just to follow up on that, but open for everyone, like when do you think is a good time to enshrine something? A lot of you guys have said like, well, you don't want to enshrine things because you want to be open to seeing the ecosystem evolve and figuring out the right way to do things. But I mean, a lot of you, maybe not all of you, would say at some point like it makes sense to enshrine something. Like most VMs have like crypto enshrined because it gives you some performance. Like, so when does it make sense, or does it ever make sense to like enshrine features like that?
So I think from a general purpose point of view, like if you're looking at it just from completely, let's say, how, let's say, different features kind of made it into CPUs over the years in terms of, let's say, SHA-56, 256 acceleration or AES encoding, so on. It's when it becomes standardized enough and stable enough to actually make sense. One thing I also just wanted to bring up a little bit in terms of kind of like the discussion about, let's say, how do you deal in intents and PPS and so on, is that mental models help, right? For developers, it helps that they can understand that that's something they already know. So for example, with a general purpose VM, like an actual Linux machine, that might have even, let's say, you can kind of visualize something like a sequencer, a little bit like a deterministic network interface, for example. It makes it easier for you to reason how these new technologies will affect your thing. Intents is basically kind of providing a solution. How do you, let's say, actually make this execution happen? And I think that's also very important in terms of kind of like not just standard, but also like sharing the mental models of people. So it's easier to reason about because like, I think, for example, let's say with FuelVM, there's a very limited amount of people who can reason about what the effect of, let's say, PBS is going to be on it.
I would say, like, you probably, so there's like a difference between enshrining and optimizing for something. So enshrining in my mind is like basically this is the only way to do these things. Or maybe like, yeah, I mean, that's how it's, but you could say this is not the only way to do things, but there might be preferred optimized way to do things, and you optimize for SHA-256 or for the signature scheme. Doesn't mean you can't use a different signature scheme to sign contracts or whatever else. It just maybe you haven't optimized and it may be a bit more costly. And then over time, hopefully as like, you know, the market or the use cases show you where it goes, you may re-optimize or rebalance some optimizations, but you, like, in terms of enshrining, kind of the definition that I use where you prohibit, like say this is the only way, you should probably make as few choices of those as possible and just say, okay, this is the absolute minimum that I will enshrine. You can do other things, they might be more costly, and this is like, and maybe this will change in the future if the use cases shift.
Yeah, I think it also makes sense to enshrine once you know that you want a brand new feature that you perhaps haven't thought about just because you're building a brand new execution environment. But I would agree that there's a difference between optimization versus enshrining itself, for sure. Yeah. But like figuring out exactly when to enshrine something and when to not is like this billion-dollar question, or in our case, the sum of the valuations of all of our companies question.
I think when it comes to cryptography, especially on our VMs at the moment, I'm hoping at least we can get to a point where, like, some of us are talking about that BLS 12 for 381 signatures haven't made it to EVM. Is it really? It's really not expressive enough to actually, let's say, do this completely general purpose thing that should entirely be possible on the EVM. So at least the benefit we have with our languages and our new virtual machines is that we can actually go ahead and add these new features that we actually need for our things and end up a standardization where it might eventually be a standardized feature.
Yeah, I think it was Cartesi, right? That's not really enshrining fees at the moment. Like, enshrining fees is something that, at least to me, and this is just my personal opinion, seems like such a complex problem. Like, how do you even know which opcode should be priced at what point? I mean, you could do benchmarks in theory, but you still don't know in what creative ways, I was going to say weird, but I'm using the word creative, ways people will use certain things. But I think fees would be a good example, right? Maybe you start off as completely non-enshrined, and over time you'd realize, Ethereum has done it, right? Where they reduced the price of call data like 3 times in the last 7-8 years or something.
Increase the price of storage.
Yes, increase the price of storage as well, kind of thing. But yeah.
There's another reason why enshrining is a thing, and I think it's different in the world of rollups compared to consensus protocols such as Ethereum. In Ethereum thinks about enshrining things sometimes to fix problems of incentives. So with proposer-builder separation and what happens with MEV, there's this concept of a relay that's, you know, kind of the semi-trusted entity that can censor, create a lot of problems, and, you know, we kind of have to deal with it today. And by shifting it over into the protocol, Ethereum is trying to, you know, move that trust into the protocol itself, and thereby eliminating kind of these middlemen, right? So that's another reason, and thinking about that. And with things such as changing the data marketplace for Ethereum with EIP 4844, that's another example where the incentives, you know, are aligned, and Ethereum wants to acknowledge rollups as the scaling solution for it. And it's the first time that at the protocol level, Ethereum will be acknowledging that rollups are the way to go, indirectly even, right? But it's a way of shifting away, you know, that off-chain incentive or those separate models into the protocol itself to solve a specific problem.
Awesome. I want to ask about like interoperability, because, you know, we're building all these VMs. We've had so many different VMs talk today, but, you know, we all kind of want to exist within this this shared ecosystem, this shared economy. So, you know, interoperability is really important between different applications, between different chains. How do you guys think of interoperability, and what is the best way for a VM to ensure that you know, it can be interoperable if it needs it? I mean, I guess there's probably the case that interoperability doesn't matter, but I'm curious how you guys think of it.
Yeah, well, happy to start. So with interoperability, I think how introspectable your chain is will be a big determining factor of how well it's going to, or how long it's going to last, basically. So, and what I mean by that is, if other chains can't get a good eye on what's happening in your environment, it's it's very difficult to build good tools and bridging around it, and so your chain becomes more isolated. So with Fuel particularly, we designed our VM to be very easily introspectable. So introspecting it from Ethereum is very, very easy, and introspecting it between Fuel VMs is very easy. One pitfall of Ethereum's design is it has a global state tree, which you have to traverse, and it also has these massive trees in general in smart contract state or just across the system, which are so enormous you can't actually use them on-chain. They're really horrible. And you can't even use them on-chain even with something like Arbitrum Stylus because it's too much data. It's just like way too much data to pay for. Like doing one proof would be like the cost of deploying a smart contract or something. So, so basically designing for introspection I think is really, really important. From the optimistic side, it's really just that everything is derivable on our side from the block headers, and so it's really, really easy to take a look at what's happened on the chain. But I think, you know, if Fuel did a ZK version, it would probably all be ZK related in terms of how you would do like shared introspection. But I could leave it to the ZK people to talk about that. So yeah.
That's a great setup. ZK people.
So at Polygon, we actually have like this kind of holistic take on interoperability, because what we're trying to do is have many L2s come together into single like interop layer. So like interop layer is a part of like Polygon itself. So like Miden is going to plug it into interop layer. The KVM is going to be part of interop layer. You know, other chains that you know, either within Polygon or from even outside can plug it into interop layer. It does have to be a ZK-based chain, because like the interop layer, one of the tasks is, for example, aggregate the proofs from all the chains, prove that recursively, and just push one proof to Ethereum. So you kind of amortize the verification cost across many chains. The other thing in there is that you can move things, move assets and funds and whatnot between chains even faster than you can hit Ethereum. So like Ethereum, you need to submit proof like once, like the most frequent once every block, which is once every 12 seconds. Or more practically, you would submit it less frequently than once every block for many reasons. But if you have this shared interop layer, you can move things between chains even before they hit Ethereum, because everything is proven to the interop layer, and then once in a while, interop layer goes back to Ethereum. But yeah, that's how, I mean, we have this, and it's, big parts of it are still under development, but we have like LXLY bridge that allows you to plug in different chains, and we're working on like this interop layer as well.
Yeah, it's in terms of interoperability, I'll focus my discussion to just like interoperability with L1, just because we all are L2s. It's like so far what we've seen with rollups is they have this bridge that is like supposedly trustlessly bridging assets into layer 2, but that's where the interoperability seems to end. Like if you ever want to use, you see liquidity fragmentation, because you see app devs literally having to redeploy everything all the way and then having to bridge all the funds and hoping to God that liquidity is enough for you to do your operations. I think we're doing something that we were inspired by with Aztec Connect, which was our previous product, wherein you could have like these Legos across L1 and L2 without having anyone to redeploy anything on L2, and just use like some kind of an L1 to L2 message passing mechanism. But as far as interoperability across other chains go, I think I was at a talk maybe 1 to 2 years back when ZK was just catching on, and people were talking about how the great thing about ZK is you could have these ZK light clients kind of thing, wherein finally you're not constrained by if a chain has light clients or not, as long as it is ZK provable. You don't need to do any kinds of sort of verification checks. You just create a ZK proof, and that's kind of like a light client at a high level. In theory, that should, although I personally haven't seen that play out in production yet, but in theory, that should mean you can finally have better systems of shared sequencing and everything else.
Yeah, I completely agree that kind of like light clients is the way forward to kind of prove machines to each other. But the thing about light clients and virtual machines talking to each other is that it's only between serious people, right? And APIs and interoperability, humans are horrible at developing these kind of things. And if we have, let's say, 1 billion app chains out there with different kind of things, I would personally vote for that whatever interface that we're making between these protocols, we let the AIs take care of it.
Awesome. I know we're getting towards the end. Do we want to do questions? Does anyone have questions? Otherwise, I got one more to go. Anything? No? Okay. All right. So yeah, to kind of wrap things up, I want to know how you guys think. We all want to bring in new developers into the space. We've touched a bit on kind of how developers might perceive the EVM. So a lot of us are coming from the EVM world, but for like an outside developer who's new to crypto, new to blockchain, like how do you guys think they would perceive your project, and why do you think it makes that your architecture, your language, whatever, makes the most sense for a new project coming into the space?
The incremental nature is really nice, like showcasing people that, hey, deploy this, you wrote some Rust code that does this, let's deploy it, and you can actually interact with it. And thinking of the chain as kind of this backend where you can deploy your application, and gradually expose them that, like, hey, actually, this is on a blockchain, and you have access to a rich environment of composable APIs. So you can actually call like an AMM, and you can do interesting things. So showcasing to people like incrementally really what they can do is very special, and in existing languages that they're familiar with and speaking a language that they're familiar with is our approach.
Yeah, so I mostly agree, but I think that one of the magical things about the internet was the point where we could sit down with Notepad, we could write something horrible in PHP, and actually start using it and uploading it to a server somewhere. And I think that we need to get back to that playfulness of blockchain. Of course, there's security, and you need to train people to do things right, and can I help those kind of things? That's the level of ease we need to get back to.
But is Solidity not the PHP of blockchain languages?
Sorry?
Is Solidity not the PHP of blockchain languages, though?
No, PHP is worse.
Probably true.
So like COBOL.
Yeah, so I used to build stuff with PHP a long time ago.
PHP was my first language.
Yeah.
I do love PHP.
Long time ago. I guess the way we think about the language experience is that we could fund development of an LLVM compilation strategy to the FuelVM and support Rust and C or whatever. We can do that, but we chose not to do that because a lot of those languages didn't feel right when you use them. So if you use C or Rust to target a blockchain, sorry, Arbitrum, but I really, really don't like it. It feels very wrong. It feels wrong because the construction of the compiler and the language is not necessarily something that was designed to target this particular kind of environment. Now, you can do it, and we are doing it, and that will happen. But instead, what we wanted to do was take the best parts of what we liked about Solidity and what we liked about blockchain programming, but also take the best parts of Rust, too, which we thought was really well organized, and combine that into a single language. So our whole sort of approach to someone is that if you're learning blockchain, learning Sway is like a good gateway to Rust, and if you know Solidity, then Sway is a good gateway to Rust. But if you know Rust, then this is very familiar for you. So in a sense, trying to bring people a little closer. And in some senses, I think the Rust syntax is very familiar. So I know that a lot of other teams are using it, like Noir and Aztec. But that's how we think about it.
Yeah, I would say, so something that I only learned after starting my career in ZK space is, even though a huge portion of ZK developments is clearly for blockchains, there is a very small overlap between people who work in ZK and the people who are blockchain devs. One of the easy lifts that we're planning to do is, so it turns out it's very, very expensive even today to actually verify a ZK proof on Ethereum. And like one of our ideas is, what if you could use Aztec smart contract language, which internally is actually just a ZK circuit, right? And that way you can onboard a lot of the ZK devs, and that way you can also onboard many people into ZK, which today can't because of how hard it is to write a circuit. I mean, it's actually insane. I have only written one or two, and I don't want to write any more because of how hard it is. But I think on the other hand, it's easy to say that, hey, look, I want Rust to be my smart contract language because almost every dev compared, almost like a huge portion of software engineers know Rust. But at the end, when you try to put it for blockchain use, you end up creating your own like libraries and macros, right? That might be Rust, but when you read it, it's just basically your own framework. It might as well be your own language, at which point, to what Nick said, might as well design your own language.
There's a small pushback here in that, like there's a difference between like forcing people to use like a domain-specific language, to write smart contracts for your application, compared to having a framework that is kind of community built and anyone can build different frameworks, right? So we provide an SDK, kind of like a lot of famous JavaScript SDKs back in the heyday when you would see new JavaScript frameworks like every day. And those are developed by the community, by people, and you don't need to use it, right? Like we're not forcing people to kind of use that DSL. Instead, we provide it, but the actual API is very low level. People can come up with better, more ergonomic approaches.
Yeah, absolutely. Plus, like doing that would also mean people can use standard libraries.
So I think the key to attracting, or two keys to attracting like developers is there are two things, and they're kind of in tension with each other. The first thing is you want people to use familiar tools. Nobody likes to learn new things. And the second thing is you want people to have fewer possibilities to shoot themselves in the foot. Like if you can provide something familiar that is also very secure and robust and reduces the possibility of bugs, that would be the ideal thing. But unfortunately, those are frequently in tension with each other. You can't do that. So you need to pick somewhere in the spectrum. You need to, okay, we're going to build like super safe language, but then it's not necessarily very familiar, or maybe it's not as familiar as something else. Or we're going to allow general purpose language, but maybe like more ways to shoot themselves in the foot. I think like we picked a point on that spectrum where we would say, okay, we're going to go for multiple languages, and we're going to try to ensure safety at the kind of VM level, and you should be able to compile from Rust. And maybe it's somewhat familiar. Notice, like you still need to have a framework and all of that stuff, but maybe it's somewhat familiar, and maybe it's a bit more safer than some other approaches. But like it's kind of like in the middle. But I don't know if there is a right answer. Like people need both, and there is no it's going to evolve over time where you get to a point where you have something that is both, but like it's difficult to get there right now.
Yeah, plus if you try to make a super secure language, basically means you're doing a lot of magic for a developer under the hood. Ironically, paradoxically, more possibilities for shooting yourself in the foot.
Yeah.
Yeah, if there's anything I could wish for kind of like for these custom VMs is that you do a little bit like the stylus people are doing, and doing like a unsafe, a little bit like Rust unsafe, where you have a risk 5 or something like that in there, you can squeeze in there, or WASM. It would make life so easier, and you can kind of like put all the dirty code somewhere.
Yeah, I think what I don't like about using general purpose stuff for blockchain is that it produces all kinds of very odd results sometimes that are not necessarily intended for your application. Like basically a lot of the compiler toolchain is optimized for CPU caching and not for blockchain optimizations. So already the compiler toolchain is like not necessarily optimizing for what you want, and then you're also in an environment where effectively like the language itself will work for a blockchain, but you'll never really get close enough. Actually going closer by virtue of a DSL feels more right. However, again, like both of these approaches I think are very valid. So I think using Rust and C and these other languages, you can do it, and it's being done. So it's great. We'll see what wins, I think. And
I think like this efficiency point is very important, because even like if you have something like that is easy to write at a high level, but if the compiler outputs inefficient code, like in our context, like efficient code is extremely important, people will go and try to write assembly and to make it more efficient. And this is like situation that you want to avoid, from people having to go and write assembly, because this is like the worst of all worlds. Like you have no high level constructs, and you also can shoot yourself in the foot very easily. So
you're saying you're not a Yule optimizer?
Yes, yeah, I mean, if you have to like go to that level, there is a failure somewhere.
It's where the best nerd cred is, though, being the Yule optimizer.
Yeah.
Awesome. Well, we are over time, so I think thank you guys so much. That was a great conversation, and thanks everyone for joining us here.
Thank you so much.